Hi everybody, welcome back to the saga of dimensional analysis. It is quite a little bit long video. I will show you guys why mu UMD satisfy the criterion for recovery and why three of them is a good choice for the primary quantities. So let me write down. Mu UMD satisfy the criteria, and also why mu UMD is good candidate for primary quantity. Okay, so I want to make some note about primary quantities. You have three fundamental dimension, right? So we have, okay, let me write here. We have three fundamental dimension. Okay, what is that? Mass, length, and time. So we have to pick three primary quantities. Okay, so the number primary quantities you pick should be the same number as the fundamental dimension, because you need three primary quantities to recover three fundamental dimensions. So what does it mean? So how can three of our primary quantities recover the fundamental one now? So let me write the definition for recovery. So definition of recovery satisfaction. Okay, so what's the definition? What does it mean for the fact that the three primary quantities can recover our core? So it means that, let me write, for mu UD to satisfy the criterion recovery, you must find 9 number. What are those 9 numbers? A1, A2, A3, B1, B2, B3, C1, C2, C3, such that okay, mu to the power of A1 times UM to the power of B1 times D to the power of C1 equal M, which in term unit. Similarly, you can also recover L and T as well. So mu to the power A2 times UM to the power B2 times D to the power C2 equal L. Mu to the power of A3 times UM to the power B3 times D to the power C3 equal T. So what does it mean? Let me reiterate, because maybe it's kind of confusing. MLT need to be recovered, right, by mu UM and D. So let me make a note here. So MLT can be recovered by mu UM and D. Okay, what does it mean by recover by mu UM and D? Mu UM and D need to do something to generate L, and to generate T. The way they can do something is to power to a random number, which is A1, A2 or A3, and then they times UM power to a random number times D power to a random number, and hopefully we can find those numbers so that it gives us m, l, t. That's basically the definition. Okay, so now we just need to find those. Once you write this down, let's go ahead and find them. Again, this is in term units, so let's see if we can find A1, A2 on that number, C2, C3. Okay, on that number. So from above, I will write these in terms of the unit. So mu, recall, is mass over length T to the power A1. Okay, I'll show you where we have that here. Okay, so similarly, you can write um velocity is mass is length over time, so L over T to the power B1 times L to the power C1 equal m. Okay, similarly, you can also say that m over LT to the power of B2, L over T for B2, L C2 equal L, and also m over LT to the power of A3, L to the T to the power of B3, L to the power of C3 equal T. Okay, so what I did is I just substitute mu for m over L over T, for L over T, and d diameters for L. Okay, and I do the same thing for m, L, and T, just the different numbers name, which is A1, A2, A3. Okay. Okay, so how can we find those numbers? Remember, I'm going to find those numbers, right? So let me go ahead and rearrange. So this one I can say m over LT to the power A1 is actually m to the power A1, L to the power negative A1, T to the power negative A1, L to the power B1, T to the power negative B1, L to the power C1 equal m. Okay. Similarly, I just replace A1 with A2, B1 with B2, and C1 with C2. So m to the power A2, L negative A2, T to the power negative A2, L B2, T negative B2, L C2 equal L, M A3, L negative A3, T negative A3, L B3, T negative B3, L C3 equal T. Okay. Okay, let's group them. So how can I group them? On the thing related to m, I'll put it, and then L, then T. Okay, so here you see, here we have m to the power A1. Okay, so just m to the power A1. Perfect. Okay. For about L, we have L to the power negative A1, L to the power B1, L to the power C1. So L to the power negative A1 plus B1 plus C1. Okay. And how about T? Okay, T, we have this T to the power negative A1 and T to the power negative B1. So let me switch it back to orange, to yellow. So T to the power negative A1 minus T to the B1 equal M. Okay, I'll group it as MLT. Similarly, you can do the same thing, just relate A1 with A2, A1 with A2, B1 with B2, C1 with C2 equal to L, and then replace AT, C3, T negative A3, negative B3 equal T. Okay, so how can we find these numbers? Now, you see, two of them have to be equal, right? So, so this is actually, if you're not clear, so this is m to the power 1, L to the power 0, T to the power 0, m to the power 0 times T to the power 0, T to the power 1 times m to the power of 1, 0 times L to the power of 0. Okay, so for those to be equal, for the left hand side to be equal to the right hand side, what happened is the power have to equal, right? So A1 have to equal to 1. On this, negative A1 plus B1 plus C1 have to be equal to 0. And then let me put it in pink. Negative a1 minus b1 have to be equal to 0. Okay. Okay. So we have how many systems? We have 3 systems right here, right? So we have a1 equal 1, negative a1 plus b1 plus c1 equals 0, negative a1 minus b1 equals 0, okay? a2 equal, okay, let me do this, a2 equals 0, okay, a2 equals 0, pink, negative a2 minus b2 equals 0, negative 8, I should write in order, okay? I have to follow a pattern. I'm so sorry, guys. Okay, so let's do the L first. Negative a2 plus b2 plus c2 equal to 1. So negative a2 plus b2 plus c2 equal to 1. And then negative a2 minus b2 equals 0. Okay. And then we have what? We have, similarly, a3 is 0. So a3 is 0, and then negative a3 plus b3 plus c3 is 0, 3 plus b3 plus c3 is 0. Also, lastly but not least, negative a3 plus b3 equal 1. So negative a3 minus b3 equal 1. Okay, you have 3 systems, right? So actually it's very similar. Actually just one system, because your goal is to find whether it is you can recover or not. There's 2 ways you can do this. You can get the solution directly, but let me rearrange, okay? And then I'll make some comments. So this is a1 times 1 plus a2 times 0 plus b2 times sorry, my bad. Okay, you have 3 systems, okay? You with me? Our goal is to solve for all the letters. So a1 times 1 plus b1 times 0 plus c1 times 0 equal 1. a1 times negative 1 plus b1 times 1 plus c1 times 1 equals 0. a1 times negative 1 plus b1 times negative 1 plus c1 times 0 equals 0. I'm gonna write in terms of matrix, okay? And then I'll explain why I write like that for y'all. So here a2 times 1 plus b1 times 0 plus c1 times 0 equals 0. a2 times negative 1 plus, okay, for it easy, it's not confusing, this one's this one, this one's this one, plus b2 times 1 plus c2 times 1 equals 0. And then we have a2 times negative 1 plus b2 times negative 1 plus c2 times 0 is 0. Oh, this is 1 actually, I'm sorry. Okay. And similarly, what do we have? We have, just replace it with a3. A3 times 1 plus B3 times 0 plus C3 times 0 is 0, 0. So 0, 0, 1. So A3 times negative 1 plus B3 times 1 plus C3 times 1 is 0. Okay. A3 times negative 1 plus b3 times negative 1 plus c3 times 0 is 1. Okay, so we have these type of, once you write like this, you can write in terms of matrix. So we have 3 matrix right here. So you can write, the first one we have 1, 0, 0, negative 1, 1, 1, negative 1, negative 1, 0. Okay, of A1. Okay, I just want to make sure I write it correctly. Of A1, B1, C1 equal to 1, 0, 0. Okay, You guys see it? So yeah, so let me just highlight so y'all see. So right like this. 1 0 0. This is, you just convert system of equation into matrix. Okay, that's what I did. Okay, similarly you can write the same thing for A2 and A3. Just replace the B. So because we write into a AX plus B, AX equal B system, so just replace the B. So you have the next one you have from for A2 B2 C2 is 1 0 0 negative 1 1 1 negative 1 negative 1 0 of A2 B2 C2 equal to what? Equal to 0 1 0 0 1 0. Similarly, you also have 1 0 0 negative 1 1 1 negative 1 negative 1 0 of A3 B3 C3 equal to 0 0 1. Okay, after you write in this system, you can solve for A1 B1 C1 A2 C2 B2 A3 C3 B3, right? Just get the formula, right? Or you can solve it right here. But however, in the case where you have a bunch of system, how would you do it, right? Because that's gonna be our problem. So actually there's a way you can find where there's a solution or not. Remember, we want a unique solutions, right? So for a system, let me make a note here. I will go on because I guess I'm kind of confusing a little bit now. So okay, I see. So from here you can solve for A1 B1 C1, right? In fact, you can solve it even here at here. Let me use a calculator. On this right here, you can solve for A1 B1 C1 already. You don't need to go all the way down. So A2 B2 C2 A3 B3 C3. Okay, let me show you this way first and then explain why we have to go all the way down. So let's go ahead and solve three equation, three unknown with me. Okay, so you have 1 0 0 1 negative 1 1 1 0 negative 1 negative 1 0 0. Okay, you get 1 negative 1 2. So 1 negative 1 2. Next one you get 1 0 0 0 negative 1 1 1 1 negative 1 negative 1 0 0. You get 0 0. Wait, and 1. Let me check again. 1 0 0 0 0 1 negative 1 1 1 1 negative 1 negative 1 0 0. Okay, it's kind of weird. Oh yeah, it's 0 0 1. So B2 0, C2 is 1. A3 B3 C3. What's that? Solve with me. We should get it's the same matrix, but you just change this one become 0. This one become 1. Right? 0, sorry. 0. 0 1, yep. 0 0 0 0 0. Wait, no way. 1 0 0 0. Negative 1 1 1 0. Negative 1 negative 1 0 0. This one. So 0 negative 1 1 0 negative 1 1 0 negative 1 1. I'm so sorry for this calculation. It takes a while, but you see the point. From this point you only get a1 b1, so it's good as long as you didn't get on 0, you didn't get something like this. As long as you didn't get something like this, a1 equals 0, b1 equals 0, and c1 equals 0. All the number equals 0. All number equals 0 in one system. In one system, you good. Okay. So yeah. So basically, you can recover. You can find all these numbers. Okay. I'll leave the matrix here. I'll explain why we need later. So let's proceed with the answer we have. So good news is we obtain on the number a1, a2, c2, c3, which satisfy the criteria for recovery. Okay, so let's rewrite on these number a1, b1, c1. So a1 is 1, b1 is negative 1, c1 is 0, right? It's 2. Okay, and you have a2, b2, c2. What's that? a2, b2, c2, 0 0 1, 0 0 1, and a3, b3, c3 is 0 negative 1 1, 0 negative 1 1. Okay, very good. So which means that you remember this equation. Okay, this equation right here. You can use this to find m, l, and t. Okay, so it's satisfied. Now, why do I introduce a matrix? What happens if you don't want to solve 3 equations at once? Okay, let me raise another question. Why do I write in matrix form? Okay, so it's a what if question, right? So what if you don't want to go on the way to find on 9 number, right? So a1, a2, c1, c2, c3. What if you just want to see, whether those number exist or not? So those number who satisfy the condition, which is not a 0 columns or exists or not. So what you're gonna do, you see the matrix right here. I write. You don't need to solve 3 equations to your nose. What you're gonna do is you write all of those internal matrix like this, right? And you notice they have the same determinant. They have they have the same determinant. This term right here. So okay, so in order to a system of ax equal b has unique solution, the determinant must not equal to 0. Okay, so you find the determinant matrix. The both three has the same determinant. Okay, it's just the vector is different, but the matrix is the same. The determinant matrix is the same. So what's the determinant matrix? So we can find, so determinant of A is determinant of the matrix 1 0 0, negative 1 1 1, negative 1 1 1, negative 1 1 1, and negative 1 0. Okay, so there's a fast way you can find the determinant of these. Let me quickly review. I was also attach the video. I will also attach the video from there. Let me review it real quick, and then I can find for you. There's a quick way. There's a quick determinant trick. I attach it in the link. So let me see how he did it. Okay, so rewrite the seam. Okay, times all that. Okay. Okay, I see. So there's a quick way you can find. So quick way to find determinant of 3 by 3 matrix. So what you're gonna do is you do like this. So you rewrite the matrix 1 negative 1 negative 1 0 1 negative 1 0 1 0, and then you rewrite the first two column of the matrix. So you write negative, you write 1 negative 1 negative 1 0 1 negative 1. Okay, and then what you're gonna do is you will okay, I see. So what you're gonna do is you're gonna cross it. So blue times it, this becomes 0. And you cross these, you times all of them, they become 0. And you cross these, this becomes 0. And then you add all of them, become 0. Similarly, you do the same thing, but you do it from left to right. So all this is let me put it here, 0. Negative 1 1 1 times together all of this, negative 1 0 to negative 1 0 is all this is 0. So you add all these, you get negative 1. So what you're gonna do is you do blue minus red, determinant of A, blue minus red, which is 0 minus negative 1, which is 1. Okay, so 0 right here, the 1 right here. Okay, so that's how you're gonna do it. Let me verify by my calculator the determinant is 1 or not. Okay, 1 second. Clear on. Where's my determinant? Determinants. Should be matrix. Shift. I forgot how to find so 1 0 0 negative 1 1 1 negative 1 negative 1 0. So determinant, how you find it, matrix, that matrix A. Okay, it's actually 1. Okay, so you get a non-zero determinant, right? You get a non-zero determinant, which means that unique solution exists. Unique solution. So which means that it satisfies the system of recovery. Oh, sorry, criteria. Okay, I attached the 2 links above. It will help you. One link is to verify the solution, the system that has unique equation and not using determinant. The second one is using the fast way to compute the determinant. Okay, so yeah, this video is kind of long, but and this is how you, there's 2 ways you can verify that your primary quantities is valid or not. The first way is you just solve for all this number, like we did here. Okay, in green over here, you find all these numbers. As long as you didn't get the all zeros group, you good. Okay, just write down and solve them. Secondly, the second way is if you don't want to go all the way and solve them, you just find a determinant, because they 3 system equation, they have the different vectors, but they have the same determinant. So you write that in term of matrix, you find determinant. If it's not 0, you have unique solutions, then you good. It means it can satisfy. Okay, thank you so much for your attention of this kind of long video. And I will see you in the next one. In the next one, we just go ahead and find a dimensionless number, proceed with the primary quantities, mu umd, which we have chosen, which we have shown why it is valid. And I appreciate your presence so much, and I'll see you in the next video.